Hi, welcome back for another 7 Caillou challenge called Simple Fun number 34, Numbers Grouping. Task: you are given an array of integers that you want to distribute between several groups. The first group should contain the numbers from 1 to 10 to the fourth. The second should contain those from 10 to the fourth plus 1 to 2 times 10 to the fourth, etc. All the way up to the 100th bucket should contain numbers from 99 times 10 to the fourth plus 1 to 10 to the sixth. And so you can kind of see that these, you heard me just say the word bucket, they're sort of, each bucket is a range of values. We'll see as we scroll down that it represents every 10,000. So all the numbers will be written down in groups to the text file in such a way that the groups go one after another. Each non-empty group has a header which occupies one line, and each number in a group occupies one line. So there's another image down here where you can see this. See these lines with the colons? They're just telling you the range of the bucket, 1 to 10,000, and then it will list every number in that bucket. Then it goes to the next bucket, tells you its range, 10,001 to 20,000, then all the values that were encountered in that range, etc., until you go through all the buckets. And I think that's the example. If you look at the tests down here, this very first one, it kind of shows you what the output would look like for that. And then notice, though, that the output's 11, because all you have to do, you don't have to actually make this text file or this string. You just have to say how many lines will be produced in the in the output file that we're not actually creating, but if we were to create it, how many lines would it have? That's essentially what this challenge boils down to. They give you that example, which I think is the same as the first test, as 11. They show you the values that go in each bucket. Feel free to read through that and convince yourself that it's true. And then because there are 7 numbers in the array, and then you've got 4 headers, right? So 7 plus 4 is 11, has 11 lines. Imagine if each value went in its own bucket, then you'd have 7 plus 7, and you'd have 14 lines. So you see how it can vary. Input, output, integer array A, not well named. Constraints, you got the length of A is between 1 and 10,000, and each element is between 1 and 10 to the sixth. Output's an integer. Yep, we can see that. So go ahead and think about this. Remember, you don't have to actually create the string. It'd be a lot of extra work. You could, if you really wanted, to create the output string and then just count how many lines you have. I suppose that's one strategy, but you don't need to do that. But go ahead and pause, have a go at this. Come on back when you're ready. I'm just going to set mine up with the formatting that I like, and then I'll go right into my solution. Okay, so the strategy for this is that I'm going to make a helper method that sort of takes any integer value in the valid range, and it will return me an integer that represents which bucket that value should go into. And then I'm going to make a dictionary with, we know that dictionaries are key value pairs, a collection of key value pairs. And so the key will be the bucket number. And then for the value associated with a bucket number, I'll create a list of integers that has every value that falls within that bucket. And the idea is then that at the end, when I have this dictionary populated, I can get the number of elements by sort of going over every key value pair, adding up the list size associated with each key, right? That would tell me how many elements there are. And then I could count how many buckets there are too, right? Because remember, buckets can have many values within them. So it could be, a lot of different values. But when I count how many buckets there are in my dictionary, that will tell me how many headers there are. So if I add those two values together, I should be good. And you know what? As I'm explaining this to you, I'm thinking I could probably just take the size of the array instead of counting all of the values in the dictionary, how long the lists are. So maybe we'll do it both ways. So first things first, let's start with that method, that helper method that's going to get us an index. So I will make a private method, and I know I've been forgetting this a lot lately. We'll blow this up a little bit. Oh no, I did it again. Safari. There we go. Okay, well, they took my formatting. That's fine. Okay, good. So I won't bother with the formatting this time. This will be a private method, and I'll call it get bucket index given an integer. Remember, A is going to be filled, this array A, it's going to be filled with integer values, and for each one, I want to sort of map it. I want to know what its bucket index is going to be. And so for this, I'm going to say, if you're just thinking about this in your head, you might think, well, I can just divide the value by 10,000, right? Because the buckets essentially go from 1 to 10,000, 10,001 to 20,000, 20,001 to 30,000, etc. And this is close, right? But imagine if we had the value 10,000. 10,000 divided by 10,000 is 1, and we actually want that to be bucket 0, the first bucket. So all I did to sort of accommodate that, because they happen to include 10,000 in the first bucket, you know what I mean? Normally you'd kind of think of it where it would be like 0 to 9,999. But to get around that, I'm just going to say n minus 1 to make this division work out. That way, if I have 10,000, you take 1 away, you get 99.99. Divided by 10,000, you're going to get that 0 value that you want. And you can plug in other values to convince yourself that this will give the correct index. The second part of this I'm going to do, I will make a local field. But you know what? You could do this right in the method itself. So I'll just do it this way. If you want to do it some other way, you can do it that way too. Remember, this is a dictionary from integer to a list of integer, the values, the bucket and its associated values. And I will call it bucket to vals, like bucket to values. Whenever I use dictionaries, I like to name them like whatever the key is, and then the word to, and then whatever the values are to help me make that mapping, to help me understand what the dictionary maps, because that's what a dictionary essentially is. I'll leave it here. I will initialize this in the method itself so that it gets cleared every time. If you don't, you'll notice that the dictionary just keeps filling up with values from multiple tests, and it's not accurate. You can feel free to try that if you don't believe me. But then in here, I'll say bucket to vals equals new dictionary from int to list of int. There we go. Now it's actually ready to use, and it will get cleared every time this method is invoked, which is what we want. So good. We have that dictionary set up. I'm going to go ahead and bring in using system collections generic. And if you look up the list class, you'll notice that it resides in the namespace system collections generic. That's why I have to bring that in. I didn't define the list class. I didn't make it. I'm using something that Microsoft made. So I just bring in that library and I have access to it. Very good. So now let's go ahead and go through our input array, right? Int n in A. Feel free to rename A if you like. And now in here, we're going to grab each value and sort of throw it in its corresponding bucket. And we're going to add buckets to the dictionary as needed. It won't have buckets for every possible value unless, you know, the input array actually had so many values that it covered every possible bucket. But when you run the tests, you'll notice they don't do that. So let's process these. We'll say if the bucket to vals contains key. We got to check if it's already present in the dictionary or not. So one thing we should also do here is, first things first, we got to get our index, right? Because remember, the bucket to vals is going to map an index, bucket index, to values in the bucket. So let's say int index equals get bucket index n, right? The current integer that we're looking at, we're going to go through all of them in the input, and this just is the current value we're looking at each step through the for each loop. So we have an index. We'll see if the dictionary contains it. If it does contain it, what do we want to do? We want to say bucket to vals, and we're just going to add I'm sorry, bucket to vals at index, right? This is going to give us the corresponding value. This is saying, hey, get the list of integers associated with this bucket. So this returns that list of int, right? And then what can we do with a list? We know list has an add method, and we'll add n to the list. So if it would have had at least one value if contains key return true, right? So then it just added a second value or a third or however many are in there. And then otherwise, it means that the dictionary does not contain an entry for this bucket yet, so we got to make one. So we can say bucket to vals add, and then we want to add the index, and we want to add the value. So that would give it its first entry. And then through this loop, you can imagine our dictionary is going to be filled as appropriate. So then at the end, we can sort of count the number of buckets to get the number of headers, right? So we could say int num headers. I'll combine this later, but I just want to do this by the numbers so you can see. Num headers would be, we got to count all of the keys in our dictionary, right? So to do that, you'll notice that the dictionary class, let me go to it for you. We'll say, let me see if I can do it right here. C# dictionary. And it's going to have a property. If we go to its properties, and it's got a count. So it'll tell you how many key value pairs are contained in the dictionary. Perfect. We use count. So just give me a little help there on working with the docs. Buckets to val count. Good. And then our number of entries would be just a.length. Before I told you you could go through and go through each key value pair and count the size of the list. If you wanted to know how to do that, I don't think you need to, but you could have num entries equals bucket to vals. And then we have for enumerables, remember there's sum where we can add up each, we provide a lambda expression, a function for how to add each element. And so what I can do is I like to use KVP as my variable name when I'm dealing with dictionaries. That's short for key value pair. And I say KVP value dot list was count, right? It's annoying that some are length and some are count. But this will say, hey, for each one of these, check the value, which is the list of all the values in that bucket, and just say how many there are. And sum will add up all those counts. And then you can imagine that would give you the number of entries. I think you can make it simpler than this, though. I got a little ahead of myself when I was speaking there. You could say num entries equals a.length, right? We already kind of have that. We don't have to do any sort of calculation here. Then the idea is you would return num headers plus num entries. And of course, you don't need to break these out into separate variables like I did here, but I like to do that in these beginner series. So something like this, I'm going to escape out and give this a shot. Let me shrink back down. I'll hit the test first. Let's see what I typed wrong. There's usually something. Okay, argument 2 cannot convert from int to systems collection generic. So what did I do? List of int. Oh, sure. I see what I did. If you want to pause the video and see the mistake I made, you can do that. What I did was, remember bucket to vals was a dictionary from integer to list of integer, and I tried to add an integer to an integer, and that clearly doesn't match the signature of this, or the generic types, the parameters of this dictionary. So what I actually need to do is, I could say a new list of int initialized with the value n. Something like this should work. Okay, I think we moved on. Only assignment call increment, yeah, can be used as a statement. That was on line 32. What dumb thing did I do there? Sure, look at this. You've probably been yelling at me for minutes now. I just put an expression in here, but I actually want to return that value. So, yeah, it's a nice noob move on my part, huh? So we hit the green there. Let's hit the attempt. Looks good. We're clear to submit. And if you wanted to see this other one, we can do this. The only catch is we're going to have to bring in link, right? Because sum isn't defined by the dictionary class. So we should get some kind of error saying, hey, dictionary of type list or of int to list event does not contain a definition for sum and no extension method found. Yep, that is a link move. Again, you don't have to do any of this, but when I initially described my algorithm to you, I told you that's how I was going to figure out the number of elements, and it just struck me in my head like, hey, buddy, you don't have to add those up. You can just get the count. But, figured it wouldn't hurt to show people how to use the sum method with a lambda expression there. So you can see it's the same thing, but this is doing more work that isn't needed, so I'm going to get rid of it. And then what I'll do, since you should be comfortable with this, we can say, I'll grab this bit, I'll put that right in place for num headers, and then we can grab a length, take that. Now we can get rid of these two, and we can put this in place of num entries. So just make it a little tighter. I think it's still expressive enough where people can understand what's going on. Hit the attempt. Looks good. I don't have any comments to clear up. So I'm going to submit mine like this. I guess I'll leave this comment here. That's fine. It doesn't hurt anything. But if you name your variables well, you could see it's kind of says the same thing as my comment. So name your variables well. And again, you could have not made a member variable here and just declared the whole dictionary right inside the method here. And that way, each time the method was called, the dictionary would be created anew. You could do it that way too, however you like. Tomato, tomato, right? So I'll go ahead and send mine off, collect those points. You get yours too. Good work for staying with me or figuring it out on your own. And then, this is nice, group by, right? So maybe you haven't used group by. You could look that up. That's a lot more succinct than what I did. Another group by there. That's very good. Some distinct. So you can see a lot of link stuff going on here, right? And you got a hash set, another data collection there. Very cool. Seeing a lot of group by here. So yeah, feel free to look through those. Oh, and look at it. We made it. Wall of Fame. Bam. Mine doesn't look as cool as the other ones, but that's all right. You know where to find me if you have questions or comments. As usual, thank you for your support for the channel, and I will see you in another video. Thank you.